Hi, I'm junwuz, and on behalf of my collaborators here at Stanford, I'm excited to share with you our meta-analysis on recent development in human motion and gait prediction. This work is submitted to the RSS 2020 workshop on robotics retrospectives. The motivation behind this meta-analysis is twofold. First, human intent is often hard to model and predict. This is usually caused by a mismatch between the observer's and the human's knowledge on the actual model and the objective function. Second, the form of locomotion is crucial for mobile robots. In everyday life scenarios, bipedal locomotion can adapt to complex environments such as staircases and muddy terrains better than wheeled locomotion. Combining these two factors, the prediction of bipedal gait and decorrelated motion could have significant applications in the field of robotics. For example, active prosthesis can better predict the user's next move and help them accordingly. There are usually two steps to human gait and motion prediction. First, we need to collect data that captures the relevant gait information. And second, data analysis is done to implement the actual modeling and prediction. Many different types of data could be collected. One of the most common methods is to use Microsoft Kinect to collect visual data from the perspective of the environment. The advantage here is that the Kinect is easy to set up and use, but the scope of the data collected could be limited. Wearable sensors could also be used to capture environment data from an egocentric perspective, and gait patterns could be inferred from the data using filtering-based techniques. As we can see from this picture, this method could capture the environmental data much better. EMG data could also be useful. Using EMG sensors together with IMUs, it can be useful in predicting gait initiation for prosthesis users, though the entire system might still be a little bit complicated to use. Other wearable sensors such as IMUs and motion capture system are also possible. For data analysis, a number of machine learning methods have been prominent in recent work. Recurrent neural network has been at the core of many methods and has proved to be effective to produce smooth and accurate short-term predictions. Long short-term memory, which is an extension of RNN, can also be used to predict human body posture. Biomechanics-based cost functions could be used to make prediction outcomes more realistic. For trajectory prediction, conditional variational autoencoders could be used combined with LSTM to predict multimodal trajectories for multiple agents. Additional methods include feature learning that model human pose by different body components, context learning, and convolutional neural networks. Overall, we found that research on data collection is relatively more mature, while data analysis has seen more new learning-based methods in recent years. We noticed there are some common approaches. For example, Kinect-based systems are good for indoor data collection, and RNN plus LSTM have been effective in gait prediction. A common trend we also see is that the uncertain nature of gait prediction has been explored more in recent work. However, there are still some unanswered questions that could be opportunities for future research. From a high level, the ultimate use cases of the predictions and how exactly predictions could help are still not quite clear. For example, how exactly can the risk of falling be reduced with the help of prediction, and how can lower limb prosthetics be better controlled if we have the prediction information? On a more detailed level, opportunities exist in both data collection and analysis. For data collection, as wearable sensor systems are getting more and more complicated, a metric for sensor limitations or complexity could be proposed. For data analysis, parameters used to characterize gait might be reduced for faster and better learning performance. Overall, our work goes over various approaches for bipedal gait and motion prediction. Please check out our paper for detailed comparisons and discussions. We hope this work could be a useful review for the field and spark more future research. Finally, the authors want to thank Luciana and Shivani for their helpful discussions and contributions.